So there's actually two parts we want to be adding into our notebooks today. Our Unit 4 overview, which is graphing lines, which will be on page 68, and that is just 2 pages, and then standard form, page 70. So if you need to pause to write that down, you can do that. And then in our notebooks, we'll have the unit overview, okay, the title on the left, the other page on the right, and then standard form with the title on the left and our other page on the right. So as we are looking at standard form here today, okay, what we're basically going to be doing in this unit is talking about how we can graph linear equations in more efficient ways than making that whole entire table that we did last time. Okay, so standard form of a linear equation is when the x and y variable are on the same side. So that's this form right here where x and y are both on one side of the equal sign. Okay, and we can use standard form to graph by finding 2 points. And the 2 points that we are going to be able to find are the x-intercept and the y-intercept. Okay, and there's a couple things here that we want to remember about the x and y-intercept. The first thing is that the x-intercept and the y-intercept both fall on their corresponding axis, right? So the x-intercept is where the line crosses the x-axis, which is our horizontal, and it's always an ordered pair that is a number, comma, 0. Okay, and our y-intercept is where the line crosses the y-axis, which is our vertical, and it is always 0, comma, a number. That piece is going to be important as we go into how and why it works. Okay, so if we want to find the x-intercept, we are going to substitute 0 in for the y value. So if we are given 4x plus 2y equals 12, we can tell that this is in standard form because the x and y are sitting on the same side of the equal sign. When we know that, we can find the x-intercept by plugging in 0 for y, which means saying y equals 0 and making this be a 0. So say 4x plus 2 times 0 equals 12. Well, 2 times 0 is just 0, so we're left with 4x equals 12. And then that's something we can solve. So we'll divide each side by 4. And we will get that our x-intercept equals 3. Okay, now remember that's really the ordered pair. It is understood that this is really the point 3, comma 0, but we're fine just saying that our x-intercept is 3. Because in an x-intercept, the y value has to be 0. So we just assume that. Okay, to find the y-intercept, we are going to substitute in 0 for x because in a y-intercept, x always equals 0. So we are going to plug in the value x equals 0, and we'll say 4 times 0 plus 2y equals 12. Well, 4 times 0 is 0, so we're just left with 2y equals 12. That's something we can solve. And so we get our y-intercept equals 6. Now, once we have our x and y-intercept, that's enough information for us to create what it looks like in the coordinate plane. Because we can plot our x-intercept at 3 on the x-axis, right? So I'm going to go to the x-axis and make a point at 3, which is the point 3, comma 0. And I'm going to go to the y-intercept, and I'm going to make a point at 6, right? Which is the ordered pair 0, comma 6. And then I can create the line that goes through those 2 points, right? I'm extending across the coordinate plane because this line really represents all of the x and y values that make this function true. Okay, but we are just using a shortcut of what we do as standard form to get to this graph. Now, we can actually make this even shorter. Because we should understand whenever we plug in a value of 0, 0 times anything is just 0, and therefore it goes away. So if I want to find the x-intercept of this problem, I can just pretend that the y isn't there because that is getting multiplied times 0 and just going away. And so all I'm left with is x equals negative 10. There isn't even anything to solve on that one, so my x-intercept is negative 10. Okay, for my y, I'm going to plug in x equals 0, which means that's going to go away. The key is to not ignore this sign because it tells me if it's positive or negative. Okay, so now I have 5y equals negative 10, and that's something I can solve. I'll get y equals negative 2. So on my x-axis, I'm going to go to negative 10. And on my y, I'm going to go to negative 2. And this is then my line. Okay, so as we start to get that pattern down, this can go pretty quick, right? If I want to find my x-intercept, I'm ignoring my y. So all I need to do is solve 5x equals negative 35, which tells me that x equals negative 7. And to find my y, I'm going to ignore my x, right? Because I'm really plugging in 0, and 0 makes it cancel out. So I have negative 10y equals negative 35. Okay, so right away we're going to see a drawback to this because now I have a y-intercept of 3.5. And Mrs. McKinney really doesn't love that idea of approximating when we're doing anything unless we have to, right? And so when we look at this situation, it's not giving us any other points. So the best thing that we can do in standard form by graphing this with this format is to approximate 3.5 on our y-axis. It's not perfect, but it's the best we can do with what we've got. Our x is negative 7. And so there's our line. Now we have a new issue that comes up with this one when y equals negative 5. Well, that's easy enough. It tells us that our y-intercept has to be negative 5. But we don't see an x value at all. So this tells us that we have no x-intercept. It doesn't exist. There isn't one. So if we go to graph this, okay, we are going to plot an y-intercept of negative 5. And now we need to create a line that never touches the x-axis, right? Even if I make my line a little bit angled, eventually it's going to touch the x-axis. And therefore, the only line I can make that won't touch my x-axis is a horizontal line. And hopefully that then sort of rings a bell because we also looked at this with making a table, right? And not that long ago, we said, well, a horizontal line was always a y equals line, right? Where x values could be whatever, but it gave us that same type of graph. This is just a different way of thinking about it. Okay, so same idea, just different approach. Okay, so number 4, nothing wrong with this one. We can go straight into finding our x and y intercepts. Okay, so if we cover up here, that'll say 12x equals 24. So we'll get x equals 2. And if we cover up here, right, that will say negative 8y equals 24. Y equals negative 3. And so our x is 2. Our y is negative 3. There's our line. Now, we also have used Desmos. So another option that you could do to check and see if you're correct, which if you are in class, we'll be doing this, is you could log into desmos.com. Right, that's the website we've used for graphing before. Click on that graphing calculator tool, and you can type this equation is exactly how you see it, 12x minus 8y equals 24, and hopefully what it graphs should be the exact same graph that we got. Okay, so on our next one, same thing. When we go to find our x-intercept, right, we're plugging in 0 for y, but that just leaves us with 5x equals 25. So our x-intercept is 5. Okay, when we go to find our y-intercept, again, we're ignoring the x, and so our y-intercept is negative 5. So on our x, we're going to positive 5, and on our y, we're going to negative 5. This is the graph we will get here. Okay, then on our last one, we have almost the exact flip-flop of what we had directly above it, right? So this tells us right off the bat what our x is. Our x has to be 4. But we don't have a y-intercept because there's no y value. So this tells us we are going to go on the x-axis to 4. Okay, but we cannot touch the y-axis. So the only line that we can make that won't touch that y-axis is a vertical line.